So in this short video, we try to connect all the concepts you have seen together in one single page. Please recall all the concepts you have seen, like solving the linear system and the meaning of determinant, the meaning of an inverse of a matrix, and the latest topic you have looked at is about the rank and nullity. And let's look at the first condition. The first condition, let's say for the square matrix with the size n by n, if you look at the corresponding homogeneous linear system by using the m as the coefficient matrix, let's say now it has the property that the system has exactly one solution because it is homogeneous. It means the only solution must be the zero solutions, right? And if you recall this fact, it's very good. In the case that for this system to have only one solution, it basically means the determinant of m must be non-zero. If you recall this fact, it's very good. These two conditions are basically equivalent. And if the determinant of the matrix M is non-zero, it is equivalent to the fact that M inverse actually exists. Or the other way to say is M is actually invertible, right? So all the three conditions here are equivalent to each other. And by the latest knowledge you have looked at about the rank nullity formula, we can add something new. Simply by the first property, that the solutions only contain the zero solution. It basically means the dimension of the null space is zero, right? It means the nullity of M must be zero in this case. And this fact, property 4 is equivalent to property 1, which in turn is equivalent to all things like 1, 2, 3, right? So it means all the four properties now are equivalent to each other. And by the rank nullity formula, the property 5 is actually obvious. The rank of M must be n now because of the fact that M now has n columns. And we have seen it already, rank nullity formula means the rank plus nullity must be n. It must be. And now all the five properties are actually equivalent. And the last one is actually clear. If you try to describe the row space or the column space, you see for the n by n matrix, basically you have n rows and n columns like this, right? And each vector, no matter you're talking about the row or the column, you actually have n coordinates. It means both the row space and the column space are sitting in Rn. And because of the fact that the rank is n, and it basically means the dimension of the row space and column space is n, and also it's equivalent to the fact that the row space and the column space are exactly the whole space Rn. Let me write it down here. So you see, now I'm claiming that all the six properties are equivalent. If you have already watched all my videos on all these topics, and in the case that if your understanding is pretty good, you could easily see that all the six properties must be equivalent. Please think about it yourself. That's the end of this video.